The MCAT podcast, session number 88. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help you get the score you deserve so you can one day call yourself a medical student. Welcome to the MCAT podcast. My name is Dr. Ryan Gray from the medical school headquarters, and as always, I'm joined by Brian from Next Step Test Prep. And this week, we're starting off a sequence of episodes all about physics, one of the hardest subjects on the MCAT. So we're going to dive into some physics to help you on your MCAT. Let's go ahead and jump right in. All right, Brian, we're back. Last 4 episodes or so, we've covered psych-soc, more of the quote-unquote easier, softer sciences. Now we've reversed gears, and we're gonna hit it hard with some physics questions.
Yeah, absolutely, right? Go to the complete other end of the scale, where instead of the softest, it's the hardest of the hard sciences, and give the listeners about a month of physics practice.
What makes physics so hard for students?
Well, so there's the metaphorical hard science, meaning there's a lot of numbers and kind of fact or truth to it, the way scientists would describe it. I mean, I think it's hard for MCAT students, number one, because of the math, right? I mean, some students that just tend to be very mathy and certainly not under pressure, right? You got no calculator on test day. And these days, everybody has a phone in their hand by the time they're like 2 years old, which has a calculator function, right? So I thought it was bad all the way back in the 90s when they started allowing calculators on the SAT. Now I feel like a dinosaur. Like now everybody's got calculators all the time. So that's a part of it. And then on top of it, there's also a lot of students tend to take physics, either, AP physics in high school, or they take it as freshmen. They get it out of the way really early. And of course, then when they roll around to their MCAT, junior year, senior year, even after college, it's been a long time since they've taken the MCAT. Since they've taken physics, excuse me. And then finally, it's also that physics is just kind of the orphan science, that it lives over on the side in a way that it doesn't often, in an obvious way, directly plug into chem and orgo and biochem and bio, and you can create this whole matrix of all your other classes where the info kind of relates to each other. And then over there on the side, you have physics asking you questions about shooting cannonballs in the air. Yeah.
and boxes on incline or decline ramps with some random coefficient of friction.
Mm-hmm, right, exactly. So I figure we get a little practice in and review some of the underlying concepts over the next few sessions for folks.
Alrighty. So as always, if you want to follow along with us, you can get the handouts at themcatpodcast.com. Go to session 88 where these will live. So I'll start here with question 6, and I will warn you right off the bat that I probably will not get any of these right. So
okay.
That is my burden to bear. Question 6, by what factor does the period of oscillation of a pendulum change when its length is extended from 1 centimeter to 9 centimeters? Oh, okay. Pendulum questions. Those are fun.
Mm-hmm.
So it's in the length has gone up by 9.
Yeah, factor on 9. So just generally, Ryan, if you have a pendulum that's a lot longer, do you imagine that it would talk back and forth or swing back and forth faster or slower?
Slower.
Right, it's going to slow down.
Yep.
And period, we want to remember, is the time it takes to oscillate all the way out and then back again.
Yeah.
So if it's going to go slower, then the period would have to do what?
It would have to increase as well. Wait, no. Yeah, it would have to increase.
More time.
Yeah.
Yep. Yeah, it takes you more time to talk out and back in.
Yeah.
Yep.
All right, so let's read the answers here real quick. So its original period is multiplied by 0.33, so that doesn't make sense because that would slow it down. Its original period is multiplied by 2, is B. C is multiplied by 3, or D is multiplied by 9. So now you just have to know the equation for period and figure that out.
Mm-hmm. Yep. So we said it's going to slow down, which means it's going to take more time. So like you said, it has to be B, C, or D. It's got to take more time.
Yeah.
And just thinking about how equations are arranged, if you take one of the variables and give it a 9x, multiply it by 9, our choices, Ryan, here are 2, 3, and 9.
Yeah.
So is there one...
I would guess D just because it's multiplied by 9 as well. So if you figure there's some like random 1x and x's pendulum length, then...
Sure, so 9 would be the directly proportional answer. That's a good one, yep. And if it were 3, that would tell you what would be the relationship between those variables.
It'd be a third.
Yeah, or more likely squared. Right?
Okay. Like squared. Yep,
square or square root, right? Yep. That would explain a 3x versus a 9x. And then for answer choice B, multiplied by 2, so like a 2x factor, that's the one that doesn't seem to fit, right? Yeah. Why would 9xing one of your variables give you a 2x multiple, a double multiple on another variable? That doesn't make a lot of sense. So even if you couldn't remember the equation, probably it's C or D.
Yep.
And in this case, it's C, because of the square root relationship, that the period is proportional to the square root of the length. Okay. So when you multiply the length times 9, period goes up by 3. The exact equation for the folks that are interested is period represented by capital T. T equals 2 pi times the square root of L over G, where L is length and G is gravity.
Okay.
All right. Let's take a look at the next question. A spring system shown below, and that's just a little diagram of a mass on the end of a spring, resting horizontally on a table. A spring system is shown below with mass M representing the mass attached to the spring, K representing the spring constant, and X denoting the distance stretched or compressed from the spring's equilibrium position. What expression gives the minimum value for the magnitude of velocity of the mass after the system is stretched and released? I'm going to read that one more time. What expression gives the minimum value for the magnitude of velocity of the mass after the system is stretched and released? So you think of like a pinball machine. I don't know if anyone plays pinball anymore. I grew up playing pinball. And that little spring with the plunger on it, you pull the plunger out when you want to shoot the ball, and you let it go, and the little thing goes, it vibrates a little bit right after you let it go. So that's kind of what they're asking us to imagine. Right, a mass on the end of a spring, you pull it out, let it go, it vibrates back and forth. What's the minimum velocity of the mass on the end of the spring? And here are our choices. 0, 1/2 kx squared, x times the square root of k over m, or x squared k over m. So we got some various algebraic representations here involving k and x and m.
Yeah. And I think springs were one of the things that I hated most in physics.
Okay.
I don't know why, but I just never jived with them, I don't think.
Mm-hmm.
So
fair enough. They can still show up on the MCAT because what they'll say stuff like bone is slightly compressible and can be modeled as a spring, blah, 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 whatever. Mm-hmm. So they still do show up on the MCAT for sure.
Yeah.
So the thing we want to know, Ryan, here is that when you oscillate back and forth, whether you're a spring that's kind of vibrating back and forth, like shocks on a car, bouncing up and down, or whether you're a pendulum swinging back and forth, in any kind of periodic motion like this, you want to be aware of what happens at the extremes. So when the pendulum swings all the way up, or when the spring compresses all the way down, or vice versa. And what happens in these periodic motion systems at the extremes, you said you don't like springs, Ryan, so we can, let's set that aside and just model it as a pendulum. Mm-hmm. When the mass swings all the way up in a pendulum, what happens to velocity?
It goes to 0.
Yeah, it stops moving for just a second, right? And then it turns around and it starts swinging back down. Same thing here. This looks like a crazy algebra rearrangement something question, when the reality was you just had to know one concept about how periodic motion works, which is at the extremes, you stop for a second, turn around, and start going back.
Mm-hmm.
So the answer is A, with no algebra at all.
Oh, that's a trick one.
Well, it's tricky. It's not.
Yeah.
It's not literally a trick question. But.
So where do if a student were to get this wrong, what's the most common wrong answer here? I could log back in. These are taken from the Next Step QBank. So if you sign up for the Next Step class or you buy the Next Step pack of 10 full lengths, that comes with the QBank bundled in for free. So this is taken from the Next Step Physics QBank. There's actually bar graphs that show you like how many students chose each answer choice. So you can kind of compare your performance to others. I'm afraid I don't have it right in front of me, so I can't tell you. Although these answer choices, 1/2 kx squared, answer choice B, is something that students should recognize, and that's a measure of the energy stored in a spring. So students might see that and kind of like trip off a little bit of memory in the back of their head and pick that, but that's not the minimum possible velocity. Okay.
Yep.
All right, question 10. A certain elastic coil has a spring constant of 100 newtons per meter. How much must this spring be stretched in order to store the same amount of energy held by a 50 kilogram mass at rest 1 meter above the surface of the Earth? I love all these springs and masses all over the place on our planet. So the answers are A, 10 centimeters, B, 31 centimeters, C, 3.1 meters, or D, 10 meters.
Mm-hmm. So this is a two-step problem, right? Very often we think of, students will make the mistake of thinking, oh, well, the discrete questions, they don't have any passages. That means they're easier. Well, not necessarily, because there can be multiple steps involved, right? So here it said, I actually want to peel the question apart starting at the end. It said, the same amount of energy held by a 50 kilogram mass 1 meter above the surface of the Earth. So let's just start by figuring how much energy is that. So there's an equation for energy, which students should definitely remember, potential energy above the surface of the Earth, which is energy equals mgh. Right? M for mass, 50, G for gravity, 10, which of course you just walk in knowing, and H, it said 50 kilogram mass at rest 1 meter above the surface of the Earth. So 50 times 10 times 1, and we've got 500 joules of energy. So that's the first step, right, is you got to recall your gravity equation, apply it, get 500 joules of energy. Mm-hmm. Then you can reread the question knowing now that what you need is 500 joules of energy. It says spring constant of 100, so that's the K, the stiffness, the spring constant, 100. How much stretch do we need to get 500 joules of energy? And so that's the next part you got to remember, which is the energy stored in a spring is 1/2 kx squared. So 500 joules equals 1/2 kx squared. And K, you were told, is 100. So you just do a little bit of algebra, right? You've got 500 equals 1/2 kx squared, multiply the 1/2 over, or multiply both sides by 2, so then you have 1,000 equals kx squared. And remember, K was 100, so you've got 1,000 equals 100x squared. Divide the 100 over, you've got x squared equals 10. And then what's the square root of 10? You don't have to know exactly, but you should know that 3 squared is 9.
Yep.
So it's right about 3 is your answer.
Okay. So you have 31 centimeters on here and 3.1 meters. Mm-hmm. Is that a very common thing that students will get tripped up on the things there?
Yeah, you gotta watch your units.
The units,
right?
yeah. That's the word I was thinking of.
Gotta watch your units, yeah. And typically you're going to be working in SI units on the MCAT. So the base unit for length is meter. So if you're doing your math and you get to 3, unless at some point you converted everything to something else, then the answer when you get to us about 3 is 3 meters, answer choice C. And you can see that in the question, right? The spring constant was expressed as 100 newtons per meter. So that you know, oh, okay, I'm working in meters.
All right, so the big take-home message here is know all of the equations for springs.
Mm-hmm. Yeah, well, no, of course, know all of the equations, period. But certainly when you're doing physics, that's going to be a big part of the problem solving.
Yeah. All right, so there you have it. Again, physics for the MCAT. Next week, we'll dive into our second episode of physics, followed by 3 and, yes, you guessed it, 4. We can count up to 4 here on the MCAT podcast. I hope this was helpful for you. We also have coming up a episode after our 4th episode, a discussion about how on the MSAR, the medical school admissions requirements, the average MCAT score increased by a lot. And we're going to talk about why that happens or why we think that happened. So stay tuned for the next several weeks. We're going to talk all about physics, and then we'll talk about the MSAR and those increases, as well as one other episode thrown in there in the middle. Don't forget to check out everything that Next Step Test Prep has to offer. They are the premier place to get your full-length test prep exams, your full-length MCAT exams. When you are preparing for the MCAT, one of the golden ways, like the golden way, or whatever you call that, the best ways, the gold standard, that's what I was trying to think of. The gold standard way of preparing is to do practice full lengths. Now, the AAMC has their full lengths that you can buy from them. Yes, it's kind of weird. They make you pay for the MCAT, and then they make you pay for the prep material. They make you pay for the MSAR and so much more. And so the AAMC, they make the MCATs, and so their test writers also have practice exams that you can buy directly from them. You can buy 3 practice exams plus a sample test that's not scored. Now, there are conversion tables and other things online that you can find, but don't trust those. So you have up to 4 full-length exams that you can get from AAMC. Next Step offers 10 full-length exams, including a half-length diagnostic and 1 free full-length. If you go to nextsteptestprep.com, you can use the promo code MCATPOD, that's all capital letters, MCATPOD, to save some money on your full-length exams, or sign up to get the half-length diagnostic and the 1 free full-length as well. So thank you for checking out the MCAT podcast, and don't forget to go check out Next Step Test Prep and everything that they can offer you to help you on your MCAT test day. Have a great week. We'll see you next time here for another episode of Physics.